Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths Practice Questions on the product rule for counting. If you need any extra help on the product rule for counting, if you go to Corbettmaths and go to worksheet number 383, there's a dedicated video tutorial there on the product rule for counting. Alternatively, you can scan the QR code on the front of this booklet. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, let's look at our first question, question number 1. So question number 1 says, Benjamin picks a 4-digit PIN for his debit card. So for his debit card, he picks a 4-digit PIN number, and each digit is a number from 0 to 9. And Benjamin can repeat his digits. So for instance, he could choose the PIN 5511 or something like that. And it says that his PIN starts with 94. So it starts 94, and then there's 2 more digits. So for instance, it could be 9417 or 9488 or 9450, something like that. And part A says, how many possible codes are there? So given that he starts with 94, we need to think about how many possible options there are for the next 2 digits. Now in terms of that, there's a couple of approaches we could use. One approach is just consider what the digits could be. They could be 00, they could be 01, 02, 03, all the way up to 99. So it could go 00, 01, 02, 03, 04, 05, 06, 07, 08, 09, 10, 11, 12, 13, and so on. So it's going all the way from 00 all the way up to 99. So they are the possible options for the next 2 digits. So altogether there would be 100 options, because from 00 up to 99, well, from 1 to 99, there's 99 numbers, and then we've got 00 as well. So that means there'd be 100 possible options for those last 2 digits. So given that he starts with a 9 and a 4, that means there'll be 100 possible options. So the answer is 100. So that's one way we could do that question, just considering what the possible options would be for those last 2 digits. Another approach is to use the product rule for counting, because in this box here we could have a 0, a 1, a 2, a 3, a 4, a 5, a 6, a 7, an 8, or 9. There's 10 possible options for what could go in that box. And also there's another 10 options for what could go in that box. So if we want to use the product rule for counting, we just need to do 10, the number of possible options that could go there, multiplied by 10, the number of possible options that can go there. And 10 times 10 is also equal to 100. So that's it. So how many possible codes are there? The answer is 100. Okay, let's look at part B. Okay, so part B says Megan creates a 4-digit code number for her debit card, and the first digit is 2 and the 4-digit code is odd. And we've been asked how many possible codes are there. So there's 4 digits, so I'm going to write down the first, so the first digit, the second digit, the third digit, and the 4th digit. And let's write beneath those how many possible options there are for each of those digits. So the first digit, well, the first digit is 2, so there's only one possible option there, 2. So there's only one option. Okay, the second and third digit, we're not told anything about those. Let's focus on the 4th digit next. We're told the 4-digit code is odd. So that means in terms of the 4th digit, it could be a 1, a 3, a 5, a 7, or a 9. Because if it ends in a 1, a 3, a 5, a 7, or a 9, the 4-digit code will be odd. So that means there's 5 possible options for that last digit. Okay, now if we go back to the second and third digit, we're not told anything about them, so all 10 digits can go in there. The digits 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. So any of those 10 digits can go in there, and any of the 10 digits can go here. So if we want to find out how many possible codes there would be, we just need to multiply them together. We just need to do 1 times 10, which is 10, times 10, which is 100, times 5 is equal to 500. So that means there's 500 possible codes. And rather than listen them, thinking of all the possible codes that begin with a 2 and that are odd and have got 4 digits, and round down the 500 possible options, this is a much quicker way to do it. So the answer would be 500, and that's it. Okay, let's look at our next question, question number 2. Okay, so question number 2 says, in a school there are 20 students in year 4 and 18 students in year 5. And the head teacher wants to interview one year 4 student and one year 5 student. And the head teacher says there are 360 possible ways to choose one year 4 student and one year 5 student in the school. And the question says, show that the head teacher is correct. Okay, so if we consider the year 4 student to begin with, there's 20 of them. So there's 20 possible options for the year 4 student. And in terms of the year 5 students, there's 18 possible options there. So if we do 20 times 18, that tells how many possible different ways there are picking 1 year 4 student and 1 year 5 student. And 20 times 18 is equal to 360. So the head teacher is correct. And just thinking about it, if we were to consider these 20 possible students in year 4, if we were to pick one of them at random, they could go with any of these 18 students. Another one could go with any of those 18s, another one could go with any of those 18, another one could go with any of those 18, and so on. So you could pair up each of these 20 students with each one of these 18 students. So if you do 20 times 18, 20 lots of 18, that'll tell you how many different possible pairings there would be. And that's it. Okay, let's look at our next question, question number 3. Okay, question number 3 says, a coach is designing a new football strip, and so they're designing a new football kit, and he's a choice of 4 different pairs of socks, 3 different pairs of shorts, and 11 different shirts. And the question is, how many different strips are there? So the socks, the shorts, and those shirts. So let's write those down. Socks, shorts, and shirts. And there's 4 different pairs of socks. So he could choose any of those 4 different pairs of socks. He's got a choice of 3 different pairs of shorts, and he's got a choice of 11 different shirts. So that means that if we multiply those together, we can find out how many different possible options there would be. So we could do 4 times 3 times 11. And 4 times 3 is equal to 12, and then we're going to times 11. And 12 times 11 is equal to 132. So that means that 4 times 3 times 11 is equal to 132. So there's 132 different strips that he could choose. For instance, he could choose the first pair of socks, the first pair of shorts, and the first shirt. He could choose the first pair of socks, the first pair of shorts, and the second shirt, and so on. And altogether, there'd be 132 different possible strips he could choose altogether. So the answer is 132. Okay, let's look at our next question, question number 4. Okay, question number 4 says, Ethan picks a 3-digit number. So he's picked a 3-digit number. So it's got 3 digits. The first digit is greater than 2. The last digit is a factor of 25. And the question says, how many different 3-digit numbers could he choose? Okay, so let's write down the first digit, the second digit, and the third digit. And let's consider how many different possible options there are for each of the digits. So we're told the first digit is greater than 2. So the possible options would be 3, 4, 5, 6, 7, 8, or 9. And altogether there's 7 options there. So in terms of the first digit, there's 7 different possible options. The second digit, we're not told anything about that. Let's come back to that in a minute. And then the last digit is a factor of 25. So let's write down the factors of 25. So 1 times 25 is equal to 25, and 5 times 5 is equal to 25. So altogether there's 3 factors, 1, 5, and 25. The last digit can't be 25 because it's just got 1 digit, so it's either a 1 or a 5, so it can't be that one. So in terms of the last digit, if it's a factor of 25, because it's only got 1 digit, the options would be 1 or 5. So there's only 2 possible options there. And then if we come back to the second digit, we're not told anything about that second digit, so that means we've got 10 possible options there, from 0 all the way to 9. So that means there's 10 possible options there. So if we do 7 times 10 times 2, we can find out how many different possible 3-digit numbers Ethan could pick. So let's work that out. 7 times 10 is 70, times 2 is 140. So that means there'd be 140 different possible 3-digit numbers that he could choose, given the first digit is greater than 2, and the last digit is a factor of 25. Okay, let's look at the next question, question number 5. Okay, let's look at the next question, question number 5. So question number 5 says, Aaron wants to buy a rug and a mirror, and in a furniture shop, there's 16 different rugs and there's some different types of mirrors. We don't know how many different types of mirrors, but it just says there's some different types of mirrors. And altogether, there's 144 different ways she can choose one rug and one mirror in that shop. And the question says, how many different types of mirror are there? Okay, so we know if, for instance, if we write down here rugs and mirrors, we know there's 16 different rugs, and we don't know how many different mirrors there are, but we do know there's 144 different ways of picking one rug and one mirror. So that means if we times the number of rugs, the different rugs, by the number of different mirrors, we get that's equal to 144. So if we do 144 divided by 16 on our calculator, it's a calculator question, that will tell us how many different mirrors there are. So 144 divided by 16 is equal to 9. So that means there's 9 different possible mirrors that she could pick from. So the question says, how many different mirrors are there? How many different types of mirrors are there? The answer is 9, and that's it. Okay, let's look at our next question, question number 6. So question number 6 says there's 3 dials on a combination lock. So there's 3 dials, and each dial can be set to 1, 2, 3, 4, 5, 6, 7, or 8. So there's 8 digits that are on each of the dials. And part A says work out the total number of different 3-digit numbers that can be used. Okay, so in terms of this, we've got 8 possible options for the first dial. So the first dial is 8 possible options. For the second dial, there's 8 possible options. And for the third dial, there's 8 possible options as well. So if we want to work out the total number of possible combinations on this lock, what we would do is we just do 8 multiplied by 8 multiplied by 8. And it's a calculator question, so if we do 8 times 8 times 8, we get that's equal to 512. So that means there's 512 different 3-digit numbers that can be chosen for the combination for that lock. Okay, then part B. Part B says work out the total number of different 3-digit numbers that can be used that have 3 different digits. So in other words, they don't have the same digit twice. So in terms of the first option, there would still be 8 possible options because you could have a 1, a 2, a 3, a 4, a 5, a 6, a 7, or an 8. In terms of the second digit, then there'd be 7 possible options because whatever's used for the first number, the first digit, cannot be used for the second digit. So it means there'd be 7 possible options for the second digit. And for the third digit, there'd be 6 possible options because whatever number's been used for the first digit and then the other number's been used for the second digit, you can't use either of those two for the third digit. So there'd be 8 possible options for the first digit, 7 for the second digit, and 6 for the third digit. And if we multiply those together, we can find out how many different possible 3-digit numbers can be picked that use 3 different digits. And the answer to that is 336. So the answer is 336. And that's it. Okay, let's look at the next question, question number 7. Okay, so question number 7 says, Jacob picks a 5-digit even number, so it's even, so we know it's going to end in either a 0, a 2, a 4, a 6, an 8. And then we're told the first digit is a prime number, so the first digit is a prime number, so that's a 2, a 3, a 5, or 7. And because it was even, we know the last digit is going to be either a 0, a 2, a 4, a 6, or an 8. And the third digit is odd, so that's going to be either a 1, a 3, a 5, a 7, or a 9. And we're told the fourth digit is the digit 8. So that's quite straightforward. There's only one possible option for the fourth digit, 8. And the question says, how many different 5-digit numbers can Jacob pick? So let's write this down. The first digit, the second digit, the third digit, the fourth digit, and the fifth digit. Okay, so in terms of the first digit is a prime number. So our choices are either a 2, a 3, a 5, or 7. So there's 4 different possible options for the first digit. The second digit, we're not told anything about the second digit, so there's 10 possible options for that, from 0 up to 9. The third digit is odd, so there's 1, 2, 3, 4, 5 different options for that one. The fourth digit is the digit 8, so there's only one possible option for that one. And the fifth digit is even because we're told the number is even, so that means it must end in an even number. So it's either going to be a 0, a 2, a 4, a 6, or an 8. So it's 5 options there. So if we do 4 multiplied by 10, multiplied by 5, multiplied by 1, multiplied by 5, that'll tell us how many different 5-digit numbers Jacob could pick. And that's equal to 1,000. So there's 1,000 different options. And that's it. Okay, let's look at the next question, question number 8. Okay, so let's have a look at the next question, question number 8. So question number 8 says, a supermarket offers a lunchtime special offer, and for £5 a customer can buy a sandwich, a snack and a drink. And there's 14 possible different sandwiches to pick from, there's 6 different snacks to choose from, and there's Y drinks to choose from. And in total there's 1,092 different ways to choose a sandwich, a snack and a drink. And we've been asked to work out Y, the number of possible drinks to choose from. So we know in terms of this, there's sandwiches, there's snacks, and there's drinks. And in terms of the sandwiches, there's 14 possible sandwiches, and the snacks, there's 6 possible snacks to choose from, and there's Y number of drinks. And we know if we times them all together, that'll tell us the total number of different ways to choose a sandwich, a snack, and a drink. And we know that's equal to 1,092. So that means if we do 16 times Y times this number, we get 1,092. So what I'm going to do is I'm going to do 14 times 6, and 14 times 6 is equal to 84, and then 84 times this number must be 1092. So if we do 1092 and divide that by 84, because 14 times 6 is 84, we'll find out what Y is. And when we do 1092 divided by 84, we get that's equal to 13. So it means there's 13 different possible drinks to choose from. And that's it. And you can check it. If you do 14 times 6 times 13, you get 1092. Okay, let's look at our next question, question number 9. Okay, so question number 9 says, Orla picks a 4-digit even number. So it's even, so it ends in either a 0, a 2, a 4, a 6, or an 8. And we're told the first digit is greater than 6. So that's either a 7, an 8, or a 9. We're told the second digit is half of the first digit. So the second digit, this digit is going to be half of the first digit. Well, that means there's only actually one option there, 4, because half of 7 is 3.5 and half of 9 is 4.5. Well, you can't have those as a digit of this number. So it must mean that you can actually only have 8 and 4, because if the second digit is half the first digit is greater than 6, well, you can't have 7 and 3.5, you can't have 9 and 4.5, so it's going to have to be 8 and 4. And then we're told the third digit is less than 6. So that's going to be either a 5, a 4, a 3, a 2, a 1, or 0. And then the question says, how many different numbers could she choose? So how many different possible numbers can Orla choose? So let's then write down the first. So the first, the second, the third, and the fourth. Okay, so we've found out that the first digit has to be 8 and the second digit has to be 4, because the second digit is half of the first digit. The first digit is greater than 6, so it can't be 7 or 9, so it has to be 8 and 4. So it has to be one option for the first digit and one option for the second digit. The third digit is less than 6, so that's either a 5, a 4, a 3, a 2, a 1, or 0. So there's 6 possible options there. And then the fourth digit, well, we're told it's an even number, so there's 5 different possible options for the fourth digit. So if we want to find out how many different possible numbers Orla could pick, we just need to do 1 times 6 times 5, and that's equal to 30. So there's 30 different possible numbers Orla could choose. Okay, let's look at our next question, question number 10. Okay, let's look at our next question, question number 10. So question number 10 says, Jackson makes 4-digit numbers using all of these cards. So Jackson's using the digits 2, 7, 8, and 9, and he's making 4-digit numbers. And the question says, how many different numbers greater than 6,000 can Jackson make? Okay, so we can approach this question 2 different ways, and I'm going to use one approach to begin with, and then I'll look at another. Okay, so in terms of the first approach, we know that the number is going to be greater than 6,000. So that means if it's greater than 6,000, it can't begin with the number 2. It can begin with the number 7, it can begin with the digit 8, and it can begin with the digit 9, but it can't begin with the digit 2. So what I'm going to do is I'm going to consider the numbers that begin with the digit 7. So there's going to be 7 and then blank, blank, blank. So let's find out how many different possible numbers can Jackson choose to begin with a 7. So there could be a 7, 2, 8, 9, 7, 2, 9, 8, 7, 8, 2, 9, 7, 8, 9, 2, 7, 9, 2, 8, and 7, 9, 8, 2. So there's going to be 6 different possible numbers that begin with the digit 7. And another way to look at it is, well, if we know that it begins with the digit 7, we've got 3 digits left. So that means we'd have 3 options for the second digit. We would have 2 options for the third digit and 1 option for the last digit. So we would do 3 times 2 times 1. And 3 times 2 is equal to 6 times 1 is equal to 6. So that means there's 6 possible numbers that begin with the digit 7. Likewise with the digit 8, so because obviously we can begin, if it's going to be greater than 6,000, it can begin with the digit 7, it can begin with the digit 8 or the digit 9, so there's going to be numbers that are in the 8,000s and numbers in the 9,000s. Okay, and again, we can consider the numbers that begin with the digit 8, so it could go 8279, 8297, 8729, 8792, 8972, and 8927. So again, there's going to be 6 different possible numbers that begin with the digit 8. And also we could work it out by doing, well, if we know it begins with the digit 8, there's going to be 3 different options for the second digit. There's then going to be left with 2 different options for the third digit, and only 1 option left for the last digit. So we could do 3 times 2 times 1, and that's equal to 6. And then likewise, in terms of the numbers that begin with the digit 9, there's going to be 6 different numbers that begin with the digit 9, because we could have 9278, 9287, 9728, 9782, 9827, and 9872. So again, there's 6 possible options there. Or if the first digit begins with a 9, then there's going to be 3 possible options for the second digit. There's going to be 2 possible options for the third digit, and there'll only be 1 option for the last digit. And if we do 3 times 2 times 1, that's equal to 6. So that means there'll be 6 possible numbers that begin with the digit 7, there'll be 6 possible numbers that begin with the digit 8, and 6 possible numbers that begin with the digit 9. So altogether there'll be 18 possible numbers that Jackson could choose with these digits that are greater than 6,000. So that's one possible approach. Another approach is, well, we could do it this way, where we said the first digit, the second digit, the third digit, and the fourth digit. And say, well, we've got these 4 possible digits, but we know the number is going to have to be greater than 6,000. So for the first digit, there'll only be 3 possible options. So there'll be 3 options for the first digit. Then in terms of the second digit, well, one of these would have been used. So that means there'll be 3 numbers left. So 3 options for the second digit. Then in terms of the third digit, we've used 2 of them, so that means there's 2 left for that one. And then in terms of the last digit, there'll only be 1 option for that. And if we do 3 times 3 times 2 times 1, 3 times 3 is 9, times 2 is 18, times 1 is 18. So again, we get 18 possible numbers, and that's it. Okay, let's look at our next question, question number 11. Okay, let's have a look at our next question, question number 11. So question number 11 says, at Corbett's Cafe, there are 7 starters, 16 main dishes, and 11 desserts. And a meal voucher allows a customer to pick 1 starter, 1 main dish, and 1 dessert for £10. And part A says, how many different ways are there to choose a meal? So in terms of this, we know there's 7 starters, 16 main dishes, and 11 desserts, and 1 of each is a meal. So if we just do 7 multiplied by 16 multiplied by 11, that'll tell us how many different ways there are choosing a meal. So we're going to do 7 multiplied by 16 multiplied by 11. And when we work that out, we do 7 times 16 times 11 on our calculator, we get that's equal to 1,232. So there's 1,232 different ways that a customer can choose a meal. And that's it, just by multiplying the number of starters by the number of main dishes by the number of desserts. Okay, let's go down to the next part. And then the next part says, 3 of the starters and 4 of the main dishes contain fish. So there were 7 starters altogether, so 7 starters and 3 of them contain fish. And there were 16 main dishes and 4 of them contain fish. And a different customer uses their meal voucher, but they do not like fish. And part B says, how many different meal combinations can they choose? So they don't want to choose something that contains fish. So in terms of the starters, there were 7 starters, but 3 of them contain fish. That means that they would choose one of the 4 other starters, because we've done 7 take away 3, and that means there's 4 that do not contain fish. In terms of the main dishes, there were 16 of them, but 4 of them contain fish. So that means that if we take 4 away from 16, 12 do not contain fish. So we've got 12 main dishes that don't contain fish. And there was 11 desserts. There's 11 desserts and none of those contain fish. So if we want to work out how many different possible meals they can choose, we would do 4 multiplied by 12 multiplied by 11. And when we do 4 times 12 times 11, that's equal to 528. So there's 528 possible meals where a customer can choose a starter, a main dish, and a dessert that do not contain fish. Okay, let's look at our next question, question number 12. Okay, let's look at our next question, question number 12. So question number 12 says, in a gym, there's 7 exercise classes on Monday, 14 exercise classes on Wednesday, and 12 exercise classes on Friday. And Max is going to attend either a class on Monday and a class on Wednesday, or a class on Monday and a class on Friday, or a class on Monday, a class on Wednesday, and a class on Friday. And we've been asked to show there's 1,358 different ways of picking exercise classes that he could attend. So let's start off by considering a class on Monday and a class on Wednesday. So in terms of Monday, there's 7 classes on Monday, and on Wednesday, there's 14 classes on Wednesday. So if we do 7 times 14, that tells the number of possible options of classes that he can attend on Monday and Wednesday. So 7 times 14 is equal to 98. So there's 98 possible combinations of classes for the classes he can attend on a Monday and a Wednesday. Okay, so now we've got Monday and Friday, so Monday and Friday. In terms of Monday, there's 7 possible classes, and on Friday, there's 12 possible classes. So if we do 7 times 12, that'll tell us the total number of possible options of the classes he can choose on Monday and Friday. So 7 times 12 is equal to 84. So there's 84 possible options there. Or he's going to attend a class on Monday, a class on Wednesday, and a class on Friday. So Monday, Wednesday, and Friday. So on Monday, there's 7 possible classes. On Wednesday, there's 14 possible classes. And on Friday, there's 12 possible classes. So if we times them together, that'll tell us the number of possible options that he can choose for a class on Monday, a class on Wednesday, and a class on Friday. And when we do 7 times 14 times 12, that's equal to 1,176. So in terms of a class on Monday and a class on Wednesday, there's 98 possible options. A class on Monday and a class on Friday, there's 84 possible options. And a class on Monday, a class on Wednesday, and a class on Friday, there's 1,176 possible options. And then if we add them all together, that'll tell us how many different ways there are of picking exercise classes that satisfy those days that he wants to go to the gym on. So if we do 98 plus 84 plus 1,176, that's equal to 1,358. So there's 1,358 different ways that Max could choose these exercise classes. And that's it. Okay, let's look at our next question, question number 13. Okay, so question number 13, we're told that James is creating a 6-digit code to lock his iPad, and he's only going to use the digits 1, 2, 3, 4, 5, and 6. and he uses each digit once, so he doesn't repeat any of the digits. And part A says, how many different codes can James create? So in terms of the codes, well, he's got his first digit, his second digit, his third digit, his fourth digit, his fifth digit, and his sixth digit. And let's write down the number of possible options for each of the digits. So in terms of the first digit, he can choose any of these, so the 6 possible options. In terms of the second digit, well, he'll have picked one of these numbers, so there's only 5 other options then left for the second digit. In terms of the third digit, well, he's picked 2 of them now, so that means there'd only be 4 left to choose from. The fourth digit, he's chosen 3 of them, so there'd only be 3 left. Then for the fifth digit, there'd be 2 left, and for the last digit, there'd only be 1 option left. And then if we do 6 times 5 times 4 times 3 times 2 times 1, that'll tell us how many different possible codes James can create. And when we do 6 times 5, that's 30, times 4 is 120, times 3 is equal to 360, times 2 is 720, and then times 1 720. So that means there's 720 possible codes that James could choose from. Okay, so now we're told that Kelvin also creates a 6-digit code, and he picks his digits from the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So he's got 10 different digits he can choose from. We're told the first digit is positive, so that means it's not 0, so not 0. So all the rest of the digits are positive. Then we're told that the first 2 digits of his code he uses a multiple of 15. So the multiples of 15 would be 15, 30, 45, 60, 75, and 90. So they're the possible options for the first 2 digits, because we're told the first 2 digits of his code he uses a multiple of 15. For the middle 2 digits, he repeats the same digit. So for the middle 2 digit, he repeats the same digit. So that means he can choose either a 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, or 9, 9. So that's what he could choose for the middle 2 digits. And for the last 2 digits, Kelvin uses an even number between 25 and 45. So the even numbers between 25 and 45, there would be 26, 28, 30, 32, 34, 36, 38, 40, 42, and 44. So they're the possible options that he could choose for an even number between 25 and 45. And then part B says, how many possible codes can Kelvin create? Now if we have a look at this, he split the 6-digit code up into the first 2 digits, the middle 2 digits, and the third 2 digits. So let's split this up into the first and second digit, the third and fourth digit, and the fifth and sixth digit. So let's start off by looking at the first 2 digits. We were told the first digit is positive, so it's not 0. And then we were told the first 2 digits of the code he uses a multiple of 15. So the multiples of 15, not including 0, 0, if you consider that to be a multiple, would be 15, 30, 45, 60, 75, 90. So there's 1, 2, 3, 4, 5, 6 possible options there for the first 2 digits. Then we're told for the middle 2 digits, so that's the third and the fourth digit, he repeats the same digit. So we've got 0, 0, 1, 1, 2, 2, 3, 3, and so on. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possible options for those 2 digits. And then we're told for the last 2 digits, Kelvin chooses an even number between 25 and 45. So we wrote down all those options. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 options there. So if we do 6 times 10 times 10, that'll tell us how many different possible codes Kelvin could create. And 6 times 10 is 60, times 10 is 600. So there's 600 possible codes that Kelvin can create. Okay, let's look at our next question, question number 14. Okay, let's have a look at our next question, question number 14. So question number 14 says, Walter creates a 5-digit even number using the following digits, and he uses each digit once, and the digits he uses are 1, 4, 6, 7, and 8. And the question says, work out how many different numbers Walter can create. Okay, so I'm going to do this question using 2 different approaches. One approach is to just consider the options, so in terms of the first digit, the second digit, the third digit, the fourth digit, and the fifth digit. Okay, now we're told that the 5-digit number is even. So I'm going to start off by considering the 5th digit and write down how many possible options there are for the 5th digit. So 1, it's odd, no. 4, yes, it's even. 6 is even. 7 is odd, and 8's even. So there's 3 even numbers. So that means I'm going to choose the last digit first, and there's 3 different possible options for that last digit. So once we've chosen that last digit, and then we're going to work out what the first 4 digits would be. So once we've chosen one of those, there'll be 4 possible numbers left for the first digit. So there'll be 4 possible options for the first digit. Now the second digit, well, we've used 2 of the numbers, so we'd have 3 of the digits left. Then the third digit, well, we've now used 3 of them, so there'll be 2 digits left. And then finally the fourth digit, there'll only be 1 digit left. So what I've done there is I've said, well, let's choose the last digit first. There's 3 possible options for that. And then there'll be 4 digits left for the first digit, 3 for the second, 2 possible digits for the third digit, and 1 digit left for the fourth digit. And then if we times them all together, if we do 4 times 3 times 2 times 1 times 3, that'll tell us how many possible different numbers Walter can create. And 4 times 3 is 12, times 2 is 24, times 1 is 24, times 3 is 72. So there's 72 possible different numbers that Walter can create. Okay, so that's one approach, and that was just to consider that last digit first. So there's 3 possible options for that. And then in terms of the first 4 digits, then you're just left with 4 digits. So it's going to be 4 options, 3 options, 2 options, and 1 option. And then just times them all together. Or another approach would be to actually just break it down a bit more. And that would be to say, well, we could start off with the digit 1 and say, well, let's start with the digit 1, and we can consider the even numbers that begin with a 1. So you could have 1 blank 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 4. You could have 1 blank 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 6, or 1 blank 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 8. So you could start off with a 1 and then have that as your last digit, that as your last digit, or that as your last digit. And then in terms of the middle 3 digits, it doesn't actually matter which way around those 3 digits go. So you'd have 3 options there, 2 options there, and 1 option there. So it'd be 3 times 2 times 1. So there'd be 6 possible numbers that would begin with a 1 and end with a 4. And they would be 1, 6, 7, 8, 4, 1, 6, 8, 7, 4, 1, 7, 6, 8, 4, 1, 7, 8, 6, 4, 1, 8, 6, 7, 4, and 1, 8, 7, 6, 4. I think I've said them all right. So there'll be 6 possible options that begin with a 1 and end with a 4. Likewise, if it was to begin with a 1 and end with a 6, you would have 6 different possible numbers there as well. You'd have 1, 4, 7, 8, 6, 1, 4, 8, 7, 6, 1, 7, 4, 8, 6, 1, 7, and so on. And there'd be 6 possible numbers there and so on. So you'd have 3 times 2 times 1, there'd be 6 options there. And 3 times 2 times 1, there'd be 6 possible numbers that would begin with a 1 and end with an 8. So altogether, in terms of the numbers that begin with a 1, you would have 6 plus 6 plus 6, there'd be 18 of them altogether. So that's if it begins with a 1. If it begins with a 4, you could have a 4, and then you could have blank, 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 and then it has to be even, remember, so it can either end in a 6 or an 8. So 6 or an 8, so 4 blank 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 8, and there'd be 6 options there and 6 options there. So altogether there'd be 12 possible numbers that begin with a 4. Or we've done 1, we've done 4, now let's try 6. So you could have 6 blank 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 4, or 6 blank 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 8. You couldn't have the beginning with a 6 and ending with a 6. And again, there'd be 6 possible numbers there and 6 possible numbers there, so that's another 12. So we've done the numbers beginning with 1, the numbers beginning with 4, the numbers beginning with 6, the numbers beginning with 7, you'd have 7 and blank 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 4, 7 blank 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 6, or 7 blank 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 8. So altogether there'd be 6 options there, 6 options there, and 6 options there. So that would be 18 options. And finally, the numbers that begin with an 8 would be 8 blank 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 4 and 8 blank 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 6. And again, that would be 12 options because 6 there and 6 there. And if you do 18 plus 12, that's 30. Plus 12, that's 42. Plus 18, that's equal to 60. Plus 12 is equal to 72. So that's it. I think I'd probably use that first approach. That approach is a bit easier, but if you wanted to check it, you can go through and work them out that way as well. Okay, let's look at our next question, question number 15. Okay, let's have a look at our next question, question number 15. So question number 15 says an ice hockey league has got 10 teams, and each team plays 6 matches against each other team. And the question says work out the total number of matches played. Okay, now there may be a few different ways to approach this question, but this is the way that I would approach a question like this. If there's 10 teams, I'm just going to label them and call them names to begin with. So I'm just going to call them A, B, C, D, E, F, G, H. Let's just check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if we go A to J, that's 10 teams. I've just called them A, B, C, D, all the way up to J. So we've got our 10 teams, and they're going to play each team 6 times. So they play each other 6 times. So A plays B 6 times, A plays C 6 times, and so on. Now what I'm going to do is I'm going to focus on if they play each other once. So if each of the teams plays each of the other teams once, how many matches would there be? So if they play each other once. So if they were to play each other once, let's see how to work out how many fixtures there'd be in total. So if Team A played all the other teams once, they would play 1, 2, 3, 4, 5, 6, 7, 8, 9 matches. So I'm just going to write 9 matches there. And that means that Team A has played all the other teams. So they've played Team B, Team C, Team D, Team E, Team F, Team G, Team H, Team I, and Team J. Okay, so they've played everyone once. Team B have played Team A. So if they were to play everybody else, well, they've played Team A. So they would have to play Team C, Team D, Team E, Team F, Team G, Team H, Team I, and Team J. And that would mean that Team A and Team B would have played everybody then once. So in terms of Team B, if they were to play everyone once, they've already played Team A, so they're going to have to play 1, 2, 3, 4, 5, 6, 7, 8 matches. So Team B have to play 8 more matches so that they've played everyone once. They've already played Team A. Now let's move on to Team C. Team C have already played Team A and Team B. So they need to play Team D to Team J. So they need to play 1, 2, 3, 4, 5, 6, 7 matches. So that means now that Team A, Team B, and Team C have played everybody else. Team D, well, they've played Team A, Team B, and Team C, but they need to play the rest of the teams. So they need to play 1, 2, 3, 4, 5, 6 matches. And that now means that Team A, Team B, Team C, and Team D have played everybody once. Team E, they've played Team D, C, B, and A, but they need to play F, G, H, I, and J, so they need to play 5 matches there. Team F, they've played Team A, B, C, D, E, but they haven't played G, H, I, or J, so they need to play 4 matches. Team G, they've played all these other teams, but they haven't played these 3, so they need to play 3 matches. And see, there's a pattern here. So now Team H, they've played all these other teams, but they have to play I and J, so that's 2 more matches. And finally, Team I, they've played everyone else, but they haven't played J, so there needs to be 1 more match there. And Team J have already played everybody. So if we add together 9, 8, 7, 6, 5, 4, 3, 2, and 1, that tells us how many matches would need to be played for everyone to play each other once. And that's it. So let's add those all up and see what that would give us. So if we do 9, so on our calculator, if we do 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1, that's equal to 45. So that means if there's 10 teams and they're to play each other once, that would be 45 matches. It would take 45 matches for each of those teams to play each other once. And that's what I mentioned. If it wasn't 10 teams, if there was 8 teams, you would do 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. And that will tell you how many matches there'd have to be for everyone to play each other once. In perhaps the Premier League, there's 20 teams in the Premier League. So if you want to work out how many matches there'd be for all of those 20 teams to play each other once, you do 19 plus 18 plus 17 plus 16 plus 15 all the way down to 1. And that'll tell you how many matches there'd be for all the teams to play each other once. Now, the question didn't say the teams played each other once. They said that each team plays 6 matches against the other teams. So it would take 45 matches for every team to play each other once. So if we want them to play each other 6 times, we're going to do 45 times 6, because there'd be 6 rounds of those matches. So 45 times 6 is equal to 270. So for each team to play each other 6 times, there'd be 270 matches, 270, and that's it. So that's it. So in this question, there was 10 teams. For those 10 teams to play each other once, there would have to be 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 fixtures, and that'd be 45. For them to play each other 6 times, we just need to do 45 times 6, and that's it. So just to go back to the Premier League example, there's 20 teams in the Premier League. If you wanted to work out how many matches there are over the course of a season, they play each other twice. You would do 19 plus 18 plus 17 plus 16 plus 15 all the way down to 1. You'd add those up, and that'll tell you how many matches there'd have to be for those teams to play each other once. And then you would double it, see how many matches there'd be over the whole season for the teams to play each other twice. And that's it. Okay, let's look at our next question number 16. Okay, let's look at our next question number 16. So question number 16 says, in a class there's 12 girls and 10 boys, and 4 of the girls and 2 of the boys are left-handed. And the teacher picks 1 girl and 1 boy at random. And the question is, what percentage of the possible pairings of students are both of the students right-handed? Okay, so let's work out how many possible pairings of students are altogether. So there's 12 girls and 10 boys. So if we do 12 multiplied by 10, that'll tell us how many possible pairings there would be. Because the first girl could be paired up with each of the 10 boys, the second girl with each of the 10 boys, and so on. So altogether, there'd be 12 multiplied by 10 is equal to 120 possible pairings. Now, we're asked what percentage of the possible pairings of the students both right-handed. So let's work out how many possible pairings of students are both of the students right-handed. So it says there's 4 girls and 2 boys that are left-handed. So it means the rest, which would be 8 girls. So that'd be 8 girls that are right-handed. And in terms of the boys, there's 10 boys and 2 of them are left-handed. So that means the rest 8 boys are right-handed. So if we wanted to work out how many possible pairings there'd be where both of the students are right-handed, we'd pair up each of the 8 girls with the 8 boys. So that'd be 8 multiplied by 8 is equal to 64. So there'd be 64 possible pairings where both of the students are right-handed. Now the question said, what percentage of the possible pairings of both the students are right-handed? So that'd be 64 out of 120. So it's 64 out of 120. And if we can convert that into a decimal to begin with, so we do 64 divided by 120, that's 0.53333 and so on. And then if we change that to a percentage, that'll be 53.333 and so on percent. So 53 and a third percent. And that's it. That's the percentage of the possible pairings where both the students are right-handed. Okay, let's look at our next question, question number 17. Okay, so question number 17 says, Chris makes a 5-digit number using all the number cards below. So he's going to use all of these number cards, 1, 2, 3, 5, and 8. And the question asks us, how many different numbers less than 70,000 can he make? So if we wanted to work out how many possible numbers he'd make altogether, we would do 5 times 4 times 3 times 2 times 1 times 0. That would tell us how many possible numbers he can make altogether. But the question is, how many different numbers less than 70,000 can he make? So in terms of that, the first digit, so the first, the second, the third, the fourth, and the fifth. Okay, so it's got to be less than 70,000. So that means that the first digit could be either a 1, a 2, a 3, or a 5. It couldn't be an 8. If there was an 8 there in the first digit column, then that number would be above 70,000. It would be an 80,000 number, a number in the 80,000s. So there's 4 possible options for the first digit. Then, once that first digit has been picked, so it's either this one, this one, this one, or this one, there's going to be 4 left for the second digit, because once the first one's picked, any of the 4 remaining digits can go into the second digit column. Once that one's picked, there'll be 3 digits left, and any of them could go there. Once the third digit's picked, any of the other 2 can go there. Then there'd be only 1 digit left for the fifth digit. So that means, just to recap, there's 4 possible options for the first digit. Once that one's picked, there's 4 left, so there'll be 4 left for the second, then 3, then 2, then 1. And then if we times them together, that'll tell us how many possible numbers Chris can make using these 5 digits, where all the digits are different, whether it be less than 70,000. And if we do 4 times 3 times 2 times 1, that's equal to 96. And that's it. So the answer is 96. Now there's another way to consider this question, and that's actually considered out in full, and actually just not to write all 96, but do a bit of a shortcut if possible. So it's got to be less than 70,000, so the first digit could begin with a 5, and then it could be blank, 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 or it could begin with a 3, and then be blank, 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 or it could begin with a 2, and then be blank, 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 or it could begin with a 1, and then be blank, 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 blank. So it could be a number in the 50,000s, 30,000s, 20,000s, or into the 10,000s. So they're the possible options we could have. And then once the first digit is in that column, then there's 4 digits left, and any of the 4 digits can go in any of the columns. So if we want to work out how many possible options would be here, so beginning with a 5 and then with 4 remaining digits, you could have 4 and then times 3, and then times 2, and then times 1, because it could be any of the 4, any of the 3, any of the 2, and then there's 1 left. And then if you times them together, you get 24. So there'll be 24 options there, 24 options there, 24 options there, and 24 options there. And if you do 24 plus 24 plus 24 plus 24, you get 96. And that's it. Okay, let's look at our next question, question number 18. So in question number 18, we're told in year 10 there's 60 girls, and 2 of the girls are going to be chosen at random to go on a trip. And we've been asked to work out the number of different pairs that can be chosen. That word's quite important in this question, different pairs. So for instance, if you've got Alice and Beth, then you get Beth and Alice. That's not a different pair. Alice and Beth and Alice, they're the same pair of students. So that's just something to keep in mind with this question. Okay, so the 60 girls all together, and if the 60 girls all together, whenever one of them is chosen at random, there'll be any one of the 60 to pick, so there's going to be 60 for the first option. Once that girl's chosen and taken out of the group, there's going to be 59 left. So then we're going to do 60 times 59, and that'll tell us how many possible pairs of names that can be picked out of the pot, so to speak. So for instance, if the 60 names were put into a pot and once 2 of them were picked out, this will tell us how many pairs can be picked out. So if we do 60 times 59, that's equal to 3,540. So that means there's 3,540 pairs of names that can be picked out. So that could be Alice and Beth, Alice and Carol, and so on. So they're all the possible options. But the question says work out the number of different pairs that can be chosen. So if you do 60 times 59, that'll pair up each of the students with each of the other students. So that'll be Alice and Beth, Alice and Carol, and so on. But then whenever we get to Beth, then it would be Beth and Alice, Beth and Carol. And notice there we've got Alice and Beth, but we've also got Beth and Alice. So what we're going to need to do is we're going to need to divide by 2 here because we've got duplicates. The pairs have been duplicated. Each of the students will be paired up with each of the students twice. There'll be the first student that could be picked out and then the second one, but there'll also be the second one and then the first one. So because we're asked to work out the total number of different pairs that can be picked, we're going to do the 3,540 and divide that by 2, because then that will get rid of the duplicates. And if we divide by 2, we get that's equal to 1,770. So that means there's 1,770 different pairs of students that can be picked. And that's it. Okay, let's look at our next question, question number 19. So question number 19 says, how many odd numbers greater than 40,000 can be created using these digits 1, 2, 6, 7 and 8, using each digit only once? Okay, so we're looking for numbers that are greater than 40,000, so greater than 40,000, and that are odd. Okay, so what I'm going to do is I'm going to start off by choosing one of the digits at the beginning. So I'm going to start off with choosing the 6 at the beginning. And we can have numbers that start with 6, and then it could be blank, 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 and then it's got to be odd, so it could end in a 1, or it could be 6, and then blank, 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 and then end in a 7. So they're the options with 6 at the beginning. There's some options beginning with 7 at the beginning. We can't have numbers beginning with 2 or 1 because it's got to be greater than 40,000. So they're the options beginning with 6. Options beginning with 7, we could have 7, then blank, blank, blank. But it's got to be odd, so it has to end in 1. It can't end in the 7 because there's only 2 odd numbers, 1 and 7. Okay, so we've got the numbers beginning with 6, the numbers beginning with 7, and then the numbers beginning with 8 would be 8, and then blank, 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 1, and 8, and then blank, 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 7. So that means that our numbers can either begin with a 6 and end in a 1, begin with a 6 and end in a 7, begin with a 7 and end in a 1, begin with an 8 and end with a 1, and begin with an 8 and end in a 7. So that means that these are our possible numbers. And then the numbers in the middle, so these 3 digits, can go in here in any order. So if, for instance, if we focus on the numbers that begin with a 6 and end in a 1, we've got the digits 2, 7 and 8. So it could go 2, 7, 8, 2, 8, 7, 7, 2, 8, 7, 8, 2, 8, 2, 7, and 8, 7, 2. So it means there'd be 6 possible options there. Or because we've got 3 digits and we're putting them in any order, there could be 3 for the first one, then times by 2 for the second, and then times by the 1 option left for the last one. And 3 times 2 times 1 is equal to 6. So there's 6 possible ways to arrange those numbers in there. And 6 there, and 6 there, and 6 there, and 6 there. So the 6 numbers that we could create, beginning with a 6 and ending with a 1. There'll be 6 numbers we can create, beginning with a 6 and ending with a 7. 6 possible numbers beginning with a 7 and ending with a 1. 6 possible numbers beginning with an 8 and ending with a 1, and another 6 beginning with an 8 and ending with a 7. And then altogether, if we add them up, 6 plus 6 plus 6 plus 6 plus 6 is equal to 30. So there's 30 possible numbers that can be created there. And that's it, 30. Okay, let's have a look at our last question, question number 20. So question number 20 says, a pizza parlor sells 10 different pizza toppings. So there's 10 different pizza toppings, such as ham, pineapple, olives, and so on. Grace orders a pizza with 3 different pizza toppings. So she's choosing 3 different pizza toppings. So she hasn't gone for pineapple, pineapple, and extra pineapple. She's just gone for 3 different pizza toppings. And the question is, how many different pizzas can Grace order? Okay, so what we're going to do here is we're going to consider the 10 different pizza toppings. So there's 10 different options. So in terms of her first choice, she could choose any of the 10. Then in terms of her second choice, there'd be 9 options remaining. And then in terms of her third choice, there'd be 8 options remaining. So if we do 10 times 9 times 8, that'll give us the grand total of the number of different ways Grace could have ordered her pizza. So she could have gone in and said ham, pineapple and chicken, ham, pineapple and mushrooms, pineapple, ham and mushrooms, so the same in a different order and so on. But if we do 10 times 9 times 8, that'll give us a grand total of the number of ways Grace could have ordered her pizza. And that's equal to 720. So the 720 possible different ways Grace could have asked for her pizza. Now the question is, how many different pizzas could Grace order? Now, because she's picked 3 toppings, this 720 will include a lot of duplicates. For instance, if there was option A, B and C. So if for instance she was to pick 3 toppings, let's say anchovies, beef and chicken, this 720 will also include anchovies, chicken and beef. It will include beef, chicken and anchovies. It will include beef, anchovies and chicken. It will also include chicken, anchovies and beef, and chicken, beef and anchovies. It'll include duplicates because it's how she could have asked for the pizza, the 720 different ways she could have asked for her pizza. So this 720 represents how many different ways she could ask for her pizza. And in terms of the number of duplicates, because there's 3 toppings, 3 different toppings, if we were to arrange 3 toppings in different orders, you'll see that there's 6 duplicates. If you do 3 times 2 times 1, that's equal to 6. So that means there's 6 versions of every single pizza. So in terms of how many different pizzas can she order, we'd have to take the 720 and divide it by 6. And if we do 720 divided by 6, that's equal to 120. So that means there's 120 different pizzas she can order. Because the 720 is how many ways she can ask for the pizza. And because the 3 different toppings can be arranged in 6 different ways, we need to divide by 6. And if you do 720 divided by 6, that's equal to 120. So there's going to be 120 different pizzas that Grace can order. And that's it. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on the product rule for accounting. If you need any extra help on the product rule for accounting, if you go to the videos and worksheets section on the website and scroll all the way down to video number 383, there's a dedicated video tutorial there on the product rule for accounting. I'll also get it to pop up at the end of this video so you can click and go directly to it. But I really hope you found this video useful. If you have found it useful, please like it and please subscribe to my YouTube channel. Thank you. Cheers. Bye.